Hi everyone, in this video we're going to look at the difference between rate of dissolving and solubility. The rate of dissolving is defined as the amount of a solute that dissolves in a fixed volume of solvent in a given amount of time. In other words, it measures how fast a solute dissolves. On the other hand, the term solubility is defined as the ability of a solute to dissolve in a solvent. So in other words, we are talking about how much a solute dissolves. I'm sure many of you out there love to eat, so these two concepts are actually very closely related to the idea of how fast someone eats and a person's appetite. So how fast someone eats is like the rate of eating, so how fast, and the appetite is similar to the concept of solubility, meaning the ability of someone to eat, which means how much you eat. We know that a person who eats very fast may not eat very much, and a person who eats very slow may eat a lot. Okay, so the two concepts are actually very different. So one talks about how fast and the other talks about how much. So we bring back this to the idea of solubility and rate of dissolving. So solubility talks about how much and rate of dissolving talks about how fast. So in this video, we're going to look at the factors that will affect each of them. So we look at the three factors that will affect the rate of dissolving first. The first factor that affects how fast something dissolves is whether or not you stir it. So in each of these test tubes, I have sugar. I'm going to add water to it. So the one on the right, you can see that when you stir it, it dissolves faster than the one on the left. So the first factor is stirring would make sugar dissolve faster in water. The second factor is temperature. So generally, the higher the temperature, the faster something dissolves. We can think about this in terms of the energy of the particles, the faster they move. Okay, so the one on the right is it has a higher temperature, so the sugar actually dissolves faster. The last factor that affects rate of dissolving is the size of the solute particle. On the left, I have fine-grained sugar, and on the right, I have the coarse-grained sugar. So to both of them, I add water, and with stirring, the fine-grained sugar actually takes only 20 seconds to dissolve completely. And in comparison, the coarse-grained sugar takes a much longer time. In this case, it took a total of 60 seconds before all of it completely dissolved. So the smaller the particle size, the faster the rate of dissolving. Now we take a look at the three factors affecting solubility. The first factor is the nature of the solvent or the type of solvent that we use. On the left, I have a beaker of water, and on the right, I have a beaker of ethanol. And to both of them, I'm going to add the same solute, potassium chloride. And potassium chloride actually dissolves well in water, but not so well in ethanol. So as you can see in the beaker on the left, after a bit of stirring, all the potassium chloride dissolves. While in the beaker on the right, you can see that even with stirring, most of the potassium chloride remain undissolved even after a long time. The second factor that affects solubility is the nature of the solute that we use. So here I have iodine added to water and ethanol, and you can see that unlike potassium chloride, iodine is not very soluble in water. So even when you stir it, you can see that most of it remain settled to the bottom. But on the right, iodine dissolves well in ethanol, as you can see, forming a brown solution. So the type of the solute, or the nature of the solute, actually plays a very important role on whether something can dissolve or not. Moving on to the last factor. Here I'm adding potassium chloride to water. And upon stirring, the potassium chloride dissolves to form a colorless solution. Now let's add more potassium chloride to water. You can expect that there will come a point in time where no more potassium chloride can dissolve. So we reach a stage where no more potassium chloride can dissolve even upon a lot of stirring, or even if you leave it there for a very long time. So at this stage, we say that the solution is saturated. And look carefully, all the undissolved solids settle to the bottom. Now, pause the video and think about what you can do to increase the solubility of potassium chloride. In other words, how can we increase the amount that can dissolve in this solvent? Well, as you might guess, if we increase the temperature, more of it can actually dissolve. So increasing temperature does two things. It makes the solute dissolve faster, and it also allows more of it to dissolve in a given solvent. So here, the undissolved potassium chloride just now managed to dissolve, and now we have a colorless solution. So we say that more potassium chloride dissolves at a higher temperature. So essentially, the higher the temperature, the higher the solubility. This is true for most of the different compounds out there. Okay, so for this curve here, you see that as I increase temperature, the amount of solute that can dissolve increases. Let's say we manage to get a larger amount of potassium chloride to dissolve at a higher temperature. What would happen if I let this solution cool? Can you see the crystals of potassium chloride that are forming on the surface? So as you decrease temperature, the solubility of potassium chloride decreases. So less of it is able to dissolve, and therefore those that cannot dissolve, they start to form crystals, as you can see on the surface here. And if I let it cool further, you start to see more and more of this potassium chloride forming out of the solution. So the lower the temperature, the lower the solubility. So the potassium chloride solids start to form again. So there you have it. Let's look at the factors affecting rate of dissolving and solubility. So the three factors affecting rate of dissolving are particle size, rate of stirring, and temperature. And the three factors affecting solubility are the nature of solute, nature of solvent, as well as the temperature.